Hello and welcome to Designing and Accessing the DT projects for years 7 to 10. So today's session is the last of 7 sessions that we've been running along the way. And as you can see, we've gone through everything from V9 of the curriculum intro, data representation, algorithms, privacy and security, and data. So if you missed any of those sessions, you're welcome to go back and rewatch them. Today, we're hoping to skip through a bit of curriculum, a bit of pedagogy, give you some resources, give you some tools and ideas for running projects, and hopefully wrap up. I'd like to introduce the two of us. We've got Drew and myself, both educators at Grok Academy. As always, we have a little bit of a look at our curriculum to know where and what we're doing. So the what do I teach you'll find in the content descriptors of the curriculum. The how do I teach it, you have suggestions in the elaborations. They're not entirely having to be done, but they are ideas for you to launch off and to get a bit of an idea about the level of each content descriptor. And how will I know they've learned it? You can see in the achievement standard. So we'll go through those now.
So, like Kylie said, let's have a look at the achievement standard. And what we're going to do for this is we're going to look at year 7 and year 8 together, and then year 9 and 10 together. But throughout this presentation, we're going to treat it as one big group because, for the sake of a lot of it, there are minor differences between the expectation that you're needed from year 7 to year 10, right? And the detail you're going in. But a lot of the ideas and the concepts that we're going to be introducing here are very similar. But looking at year 7 and year 8, there's really 2 sentences that we wanted to pull out here. This is the achievement standard straight from the V9. And it says here, by the end of year 8, students develop and modify creative digital solutions, decompose real-world problems, and evaluate alternative solutions against user stories and design criteria. They also use a range of digital tools efficiently and responsibly to create, locate, and share content, and to plan, collaborate on, and manage projects. Similarly, in year 9 and 10, by the end of year 10, students develop and modify innovative digital solutions, decompose real-world problems, and critically evaluate alternative solutions against stakeholder-elicited user stories. They use advanced features of digital tools to create interactive content and to plan, collaborate on, and manage agile projects. So you can see there is a bit of overlap. There are some terms there, though, that you may not have seen before or you may not have a lot of experience with. And we'll go through those throughout the presentation. But when we're looking at a project and when we're looking at designing and the subsequent assessment of a project, we really want to start to tie together several of these content descriptors to create a meaningful solution. And this is the thing that we really want to talk about, is it must be meaningful to a student's context. And that's on you as the teacher to know what is meaningful to them and to really draw it out so that they feel as though they have some ownership of the idea that you're presenting, whether that's going to be in what it is that you're looking at, how you're addressing it. This is where the personalization aspect comes in. So we want to tie together a lot of that. And you can see that we've also mentioned algorithms, data representation, privacy and security, and data acquisition. We're not really going to be talking to them today. We're going to be looking at the main stages of what we're going to call the design process, because that design process is what we're going to be implementing in a project. But what we want to do is we want to embed digital literacy skills and digital tools in order to collaborate and manage. And if you look in the curriculum and in the digital literacies area, you'll start to see some overlap between digital literacies and digital projects. So we're going to use the opportunity to try and hit a lot of that as we go. But we're going to look at the design process. And we've got an example here to show you that this process is ongoing and it's really meant to flow into one and from one to the next, to the next, to the next. So we're going to start at the top with investigating and defining. Then we'll move to generating and designing. Then while we're doing that, we'll do collaborating and managing. producing and implementing, and then evaluating. And then we can go back and the cycle would continue again. But we're going to look at one pass of this for the moment.
With investigating and defining, the content descriptors for these ones, we're concentrating on 7, 8, 9, 10. Define and decompose real-world problems, so that's that meaningful solution, with design criteria, creating user stories. In 9 and 10, we've added, as you can see there, stakeholders as well. They need to go off and interview them as well. So let's have a look at what some of those new terms or old terms mean. So real-world problems that exist that aren't fictional. So something quite meaningful for the students and actually draw on something either around them or something that they feel that they have impact with, a bit of a purpose for them. And each question, as you develop them, should have an audience, should have a purpose. So design a digital solution for teachers to order coffee for the new cafe. Design a solution to monitor water usage for the ag study students in the garden and to be sustainable, so it has a purpose. Design an interactive digital solution to engage prep students in one of the 17 UN goals to make the world a better place. Again, a purpose. And year 9 and 10, they might decide to go off and interview those stakeholders as well. So we've got some terminology as well, continuing with decompose. What does it mean? It means to be pulled apart. It means to pull them all apart and have a look at what each bit looks like. And it might take a little bit of research as they tease apart that problem and go through it. And a stakeholder is anybody who's linked to the project. So as students go through, they might decompose everything to do with all the stakeholders and their needs and their expectations for this digital solution. And they might look at all the different ones, everyone from internal to external stakeholders.
It's probably worth mentioning here that the real world problem that you come up with, that can be addressed in many different ways. You as the teacher might decide that you want your students to develop the question and you might co-design that with them. You might present to them a scenario and say, what problem would we look at addressing? But in this investigate and defining phase, it's about taking that problem and really drilling down into why that's a problem. What are the different parts of the problem through the things that Kylie mentioned, like decomposition.
Here's an example of a grade 7 level decomposition. This one has used some of those Microsoft tools to do a bit of a pull apart. And you can see there that they go through each individual strand, and the more that they pull apart and the deeper they delve, the better their decomposition. And by decomposing, they come up with things such as the criteria. They might even look into some of the user needs. They might look into some of the digital solution needs. They might even discover parts around the problem. So this one, for instance, if it was the agricultural studies class, had to be sustainable, they might look at what sustainability means, what sort of things have to go into it. So by pulling it apart, you can see that they've really given it some thought. Sometimes bits of research can be shown in here. Sometimes parts of code snippets that they're thinking that they might need to use as well. So that's a year 7-ish process. I love using something like this, but I find that students get very locked into the technology, and sometimes the best way is paper. So I think I've got another version of a mind map there, and you can see there that that's using a different product to mind map using color. As long as it shows the what, the why, the when, the how, all those sorts of questions, and they can tease it apart. So it always helps to model to students too, how to decompose, what a C standard or a mid-level standard, what a high standard would look like, and talk about and model the why that would be. We're on to user stories. So this is where students get it into their heads that they're not creating this digital solution for themselves. Teenagers often forget that it's not for them. They're actually creating for another person. And so that user is separate to themselves. They're more the software developer. So it'll take a little bit of work from your end to emphasize that. And it consists of a short statement as the who, the what, and the why. So as a user, I want to do what so that I can, what are the plans? So it always helps for them to understand, and then that will inform some of the criteria that they will develop later. They will also go back and they'll check that their prototype and that their design meets the user and their needs because it's being developed here. 9 and 10s, you'd go out and actually research the people and do some data gathering on that one. So let's have a little bit of a look at what happens next.
This is also a term that is new to version 9. So this is a term that you may look at and go, oh, I don't know what user stories are. But like Kylie said, they are made to be very simple and to put students in someone else's shoes.
So the design criteria, you have a look at the decomposition user stories that you've created and the problem itself to determine all of the things that it needs to have in order to be successful. So a few things go into the design criteria. You've got constraints, things that will limit you or things that you've got to meet, user stories, and the solutions requirement, things that must have. So they all get listed down. So they'd make a checklist of all the things to tick off. If we were doing the Smart Garden one, where the Ag Studies class has concerns about their water level, they want something to check the water level. We have done up a little criteria for this one. Okay, it's got to be a digital solution because the question said so. They decided after their decomposition that it needs to somehow message the students, that it monitors the moisture levels, that it uses a sensor, that it can be used outside where the garden is, and that it's easy to use. So they've come up with those ones as the design criteria, and that works quite well.
So once we've really looked into that definition of the problem, of the solution that we want to address, and looked at those user stories, we now want to get into starting to generate and design. So the content descriptions for generating and designing, there's only 4 of them. So 2 for 7, 8, 2 for 9, 10. Design the user experience of a digital system, generate, modify, communicate, and evaluate alternative designs, and design and prototype the user experience of a digital system in 9 and 10, and generate, modify, communicate, and critically evaluate alternative designs. And you can see here, this idea of alternative designs is something we're going to touch on in a moment, but it is really important to have students realize that the first solution that they're often going to come up with isn't the best. It's a stepping stone. And a lot of the things that we're going to be looking at, particularly around agile processes, are designed to encourage that iterative nature of fulfilling projects. So this, when you start in 7 and 8, you can see here that in year 5 and year 6, they've got to design a user interface. And there is a difference between user interface and user experience. And then once they do that in 7 and 8, they've got to start to prototype that in 9 and 10. So a digital system is a system, you can see here, that processes data in binary, is made up of hardware controlled by software and connected to form networks. And I'm sure you could think of many different digital systems that we could do. The ones that we're going to focus on here are the microbit. And also, if you're in 9 and 10 and you'd like to extend on some of these ideas, that's where we start to look at things like the Arduino microcontroller.
Yeah, could even be things such as an app on your phone, though, couldn't it? It's just
definitely
between a phone, a desktop computer, a little microcomputer. Excellent.
Yeah, and even something as simple as a remote control is a digital system. So let's get into user interface. In year 5 and year 6, we design user interfaces. A user interface being that way that a user interacts with the digital system in whatever way that might be. And it's going to be different depending on what the purpose is, what digital system is, what digital system you're going to be using. But the interface is purely just that, how I, as the user, interface with the system. As we get into user experience, though, in 7, 8, 9, and 10, we need to go further in. It's an elaboration upon user interface, is user experience. So it is the whole system. It's the way that the user not only interacts with the system, but how the system interacts with it. You all have hopefully, or maybe not hopefully, used systems where, in whatever form it is, it wasn't fit for purpose. That you've had that negative user experience with the app. It's that it might have loaded too slow. It might have been too many screens to click through. The whole way that you interact with it for your purpose is wrong. That interaction and that whole system that interacts with you is the user experience. So we need to look at efficiency. We need to look at simplicity. We need to look at the ease of use. All of these things come into play with user experience. If you need to touch on a phone app where there's so many taps to get to the same screen, you go, oh, I know that it could be different to that. I know that it could have given me a bit of feedback here. My phone could have vibrated to show that I tapped it. That's user experience. And you can see here that there's a really easy way to sort of interface with some of that user experience, particularly in the early phases of a design project. And it's the idea of looking at wireframes. So here's an example of a phone app, and the type of app that it is doesn't really matter. But you can see here that we've got a few different things that we can do. We illustrate that we touch the app by tapping on the screen, and then it takes us to this particular interface here where we have text, we have a password, and we have a button that signs in, which takes us to another screen. And you can see this idea of the way that we interact with the computer or with the system, and how the system processes that information and feeds it back to us in forms of a new screen or feedback or whatever that might be. That's where we need to start to illustrate this, how we interact with that peripheral. And this is where some of the work that students did in that design, in the decomposition phase, can really come in. By having the purpose be clear and by having the solution be fit for that purpose, that's where we know what we want to do, so we can start to make the user experience for our users much better overall. We can annotate these on the sketch. We can show on these wireframes that we're going to illustrate with a little bit of haptic feedback or something like that. We're going to make the screen flash or change a darker color when the user taps on the screen. This is where we still haven't created anything yet in terms of a physical, tangible product. But these are the really important phases of the design process, because if we don't have our requirements and our constraints and everything that Kylie mentioned before clear, the solution that we create will not meet what we wanted it to do, will not solve the problem that we wanted it to solve. So we really need to step students and scaffold students through these early phases so that they themselves can be more aware of what it is they're trying to actually create with their solution, whether that's on a microbit, whether that's on an Arduino, whether that's on a video game. And it's here that we also want to talk about alternative designs. So we mentioned that there's a real emphasis on alternative designs, and it comes back to that decomposition as well. When we decompose and we come up with a number of different solutions, that iterative ideating that we're going to be doing is where we can start to tease out some of those different purposes, depending on our audience, depending on the hardware and software that we have available. By creating alternative designs, alternative solutions to the product, we're really emphasizing that the way that our design, the way that our project meets our solution can be different. And this is where we need to incorporate evaluation, whether it meets the criteria, and in particular feedback. And some of those year 9 and year 10 ideas of stakeholders and interviews and surveys are a really great opportunity for us to do that. How is the user experience? Does it actually meet the criteria? Does it do the job? Does it do the job well? Is there anything that we can change from option 1 to option 2 to option 3? Is there anything that they all do well that we go, well, this is something that we must include in our final project? And when we're doing these alternative designs, This is also where some of the agile features that we will get to more towards the end can really start to come into play with that constant iteration. So once again, if we have a look at a very simple sketch of a mobile phone app, we can start to see the way that the user progresses through our solution. We can start to see where our purpose might be for this particular app, but for any solution that we're going to do. The important thing is that as we're getting that feedback, as we're evaluating that criteria, we're making modifications. We are identifying where the solution is going wrong, or maybe not even going wrong, but where it may need more refinement, more work, and how we can do that. Nobody is expecting a student to have this perfectly done on the first try. We want to see students go through a process of ideating, of creating alternative designs. That's what's going to meet that criteria. And as we get into producing and implementing, which Carly's going to go over in a moment, that's where we can really start to delve down into actually having our project be fit for purpose. So you might want to design 3 different ways that a microbit can be held outside in some way that will make it fulfill that criteria of being permanently outside. Some might work, some might not work, but we want to see that ideation.
And that modification, Drew, that you were just talking about could be as simple as using a different coloured pen on the sketches to show how you're changing it, or if your mind map needed changing, just a different coloured pen would be fine. So for me, this is the stage where I would perhaps hijack it and make sure I get a first draft from my students, because they've been working on paper, like A3 paper, A4 paper. Usually it's the faster way to go. And I would take that in, copies of it anyway, so that before they can progress on to the next stages. So just to help them chunk so that it doesn't become overwhelming, and then they feel that they've handed something in, they've given it out. And if they want to come back and improve things later, there's no marks for a perfect, improved, gorgeous thing in the first hit. In fact, there is more marks by showing changes and modifications.
You're exactly right, and even this is a really good chance to build in some of that assessment time, where we all know that in schools it's chaotic. People come in, people come out, people need to take leave. If we're building in these drafts, for whatever reason, we have a clear progression of data and what students have been doing at these different points.
Oh, for sure, yeah. So as we move on to producing and implementing, this might be a nice time to put these content descriptors within your project. And we covered these a fair bit in Algorithms 1 and Algorithms 2 in previous weeks. We spoke a lot about the changes and the dynamics and examples of designing your pseudocode and your flowcharts, and representing those, and then testing them out and tracing them just to check they've got errors way before the students even get on platform and start coding. So this fits really nicely in because it does mimic the project phase, because they are designing and putting all their effort into designing, getting it right, getting feedback, making sure it works before they spend all that precious time doing the coding. So it's a nice bit. And again, take in the draft. At this point, it works really well. And the next slide, I think, yes. So just if you've forgotten from last few weeks when we're doing Algos 2 and Algorithms 1, we spoke about what debugging is. We spoke about what tracing is. We spoke and reminded you that general purpose programming language is now in, and specifically in, because the Blockly or the drag and drop and the visual programming is no longer within grade 7 and 8. So they've specified that nicely, and object orientated. So it helps if in 7 and 8 you introduce the same program that you can continue through to year 9 and 10, something that has things that could be progressed all the way up to senior even, so that the students can increase their skills as they go. So something like C#, Python, JavaScript, they're all object-oriented programming languages. If you're looking at general purpose, you're not looking at HTML. That's somewhere else in the content descriptors. Same with SQL. So Python, it's always a really good go-to. Java, also very good one.
And as students are coming through and actually doing their producing and implementing, you really want to be drilling down into that debugging and really showing them that debugging is a skill and it's not going to be something that they're good at. And by really explicitly mentioning it in the content description, it shows that it really does need to be important, and there has to be an importance placed on it as students are progressing through their projects. They're going to come across them at some point in their life. And if you're not, you're probably not writing programs that are complicated enough for this level anyway. No one's perfect.
It's that computational thinking too, isn't it? So we're just developing their problem solving skills. Great life skills, these ones. So after we've finished with generate and design, and if you take a little sideline like I do into produce and implement, it's time to finish up. And they have created either a prototype or they've created some sort of design that they've finished with, and now it's time to evaluate it. So evaluation progresses just like every other content descriptor from 5 and 6, 7 and 8, 9, 10. And you can see here in 7 and 8, we're looking at things like evaluate existing solutions. So that's really nice for that we do, you know, together, so that the students, you model it first, you do one with them, and you have that stage release. And then you have the student solutions, which if they finish their project and they've got their design, they go back, they check their design criteria and user stories and just check that everything is as it should be. And unfortunately, I think students are like this everywhere. They think their design is it, but they've got to give reasons for it. They've got to give facts for it. So I find that students all go, well, yeah, I've done it all, but not quite. No, you've got to tell me why you think you've done that. What backs that up? So always have reasons for it as they go along. So does it do what it says it was going to do, and why? So a good reflection time for the students as well, to see if it did do all of those things. Sometimes this does take a fair bit of modelling for students so that they can understand the sort of format that evaluation would be. I think we've got another slide there where, say we've got the Smart Garden again, that the Ag Studies students have. Any of the changes the students made, they might apply the criteria to their design, the reflect, they might, think about the way they worked, they might apply the user story, and that all goes into their evaluation. So, for instance, if they say, oh, yes, it meets the criteria, what evidence do they have to support the view that it meets the criteria? So out of each of the criteria, what did they do to make sure it does do that? Did they run a test? Did they get some feedback? Did they try it out? What did they do? And if you're struggling with any of these things in projects, we've got a really valuable resource for a teacher resource at Grok, and it goes through the whole group work, user stories, personas, evaluating process. And it's got a whole lot of black line masters in the back to help students reflect, to help build that capacity for students to be able to think outside of their own heads and to apply all sorts of tests to their projects.
And we'll come to collaborating and managing now. And even though we're addressing it last, this is something that's going to come across your entire project, right? We're mentioning it last, but we want you to have an idea of that rough progression of a project before we build in these collaborating and managing parts. So if we have a look at the content descriptions here, we can see select and use a range of digital tools efficiently and responsibly to share content online, and plan and manage individual and collaborative agile projects. In 9 and 10, use simple project management tools to plan and manage individual and collaborative agile projects, accounting for risks and responsibilities. And there are, again, some words that you may not have seen before from version 8.4 coming up into version 9, particularly around agile, which we've kind of hinted at and spoken to very briefly at the beginning of this presentation. The one that we want to look at, though, and the one that we want to spend a little bit of time on is this agile projects. And agile projects is a really interesting term because a lot of people take it to mean a whole heap of different things. When we say agile projects in the Australian curriculum, we do not mean that you have to go all in on Kanban or Scrum or extreme programming or any of those ones that you might have heard. What we're looking at is more similar to the Agile Manifesto, which was released, it came out in about 2001. And you can see it over on the side of the screen here. It says, we value these things over the other things. We value individuals and interactions over processes and tools. We value working software over comprehensive documentation. We value customer collaboration over contract negotiation. We value responding to change over following a plan. That's not to say that the ones on the right, they don't have their place, because they definitely do. But as we're going through designing a project, we want to be iterating and coming back and doing stages again so that our final solution is better for purpose. We want to be coming up with new user stories as we iterate through our project. And we go, oh, that's something I didn't think of before. We want to be getting feedback at all stages to then inform our practice so that as we change, as we change and we iterate upon what we've done before, we're meeting that feedback. We want to be finding errors. We want to be prototyping. We want to have constant little things that we're doing repeatedly as we're developing. This is in line with a lot of what is in industry. Not a lot of use of the waterfall model anymore, where you're locked into regimented phases. We want this to feel more natural, and we want a more fluid approach so that students are continually evolving and developing. So let's have a look at some project management tools. Because this is meant to be collaborative over the entire length of the project, we need project management tools that are going to assist us in that. And whether you're in year 7 or year 8 or year 9 or year 10, there are a bunch of different ways you can do it. There's no one particular project management tool that is going to fit purpose. You might have experience with a project management tool that you go, I think this is much better. And if you do, please use it. But at a core, using things like Microsoft Planner, which is built into the Microsoft Office 365 suite, is a simple way to iterate some of those Kanban ideas around tasks and adding in user stories and illustrating the process. These are collaborative, so you can add a team into a particular board, which then comes in and you can edit the different stages and document where you're at with the different stages and illustrate how your project is progressing, whether that's every single thing that every single task that you're going to be doing throughout the project, which you move over from, initiating to planning to executing, or to do, in progress, done. There's no set names, there's no set nomenclature that we're going to use here. It needs to be fit for whatever purpose you think it's going to be for. There's a simpler one called a Gantt chart, which has been taught before, which just lists the tasks down the side against the time. It can be done in a program like Microsoft Excel, although there is more custom purpose software out there. That purely just shows, here's a task that I think I'm going to do. Here's how long I think it's going to take, and here's who's going to be doing it. And we might use things like color coding to show how we're going to manage that and who's been given what role and what particular stage of the process it's at. It allows us to see at a snapshot where the team is at working on a project. And I need to say team because these are collaborative. You ideally should not be doing anything here in isolation as a student. It should be in teams. Even just from the value and the expertise and the different backgrounds and the pathways that it took students to get to where they are now can bring a richness in that isn't there if you're working on your own. The collaboration is very, very important. Whether that's pairs, groups, again, whatever your school's context is going to determine that. These tools are here to support rather than force you into a different way.
Mm.
If we're looking at 9-10 though, this is where we're going to start to use GitHub. And I don't think we're going to look at GitHub today because we just don't have the time to delve into the world of Git. But it is mentioned in the elaborations. And although the elaborations for this are optional and they're suggestions, it's very valid. GitHub is an industry standard these days. There aren't a lot of projects. You can see here, this is the Arduino IDE GitHub page that we just took a screenshot of. Because it's open source, all of the code is out there. If you have a team collaborating on a project that involves programming, by using GitHub or another one like GitHub, there are a few different sort of project management things out there, we can start to save those changes, use that version history, use commenting, while also keeping it relevant to the students, because GitHub is relevant if they want to pursue this in industry. Because no matter what we do, the idea of planning is the most important, right? There is no plan that's going to go step 1, step 2, step 3, step 4, step 5. You can see here that the idea of a project actually happening is never smooth. That's why we discuss agile. That's why we discuss debugging. That's why we discuss planning and designing and really drilling down into what a project needs in order to be solved before we begin, so that we can start to mitigate some of these problems and not even mitigate, but really lean into the fact that it is going to go back and forth and there's going to be mistakes as we progress through. So as we're collaborating and managing our project, hopefully most of these should be illustrated already. But if they're not, by using some of those design tools, there's a really good chance for us to not only keep track of that, but also give students experience in working together in a scaffolded way that doesn't rely on them relying on a USB that has everyone's code on it that one day gets lost, or the student being away for a week and all of a sudden the students can't progress on a task, right? From a more practical level, this helps you as the teacher, helps the students as team members completing a project to complete the project. And it gives you as a teacher a chance to, like with Kylie said, with drafts, to get a snapshot of a project at any particular time. So that if something happens, you have data on students where they're at completing their projects, to know whether they're on track or off track, whether they're great to keep going, or whether they might need a little bit of guidance and a little bit of one-on-one time to complete or ideate or wherever it is they're up to. So before we move on to the resources, hopefully that's given you an idea. We haven't wanted to go too hard into saying you must do this project in this step, then this step, then this step, then this step. We want you to realize that it needs to be very natural. It needs to be very flowy. It needs to be very contextual for students. That's where they're going to get the most benefit out of it. That's going to be where it feels the most relevant to them. And that's where you're going to find, hopefully, that they're more engaged as they continue through a project by having those steps clear, by having that scaffolding, but also being flexible enough to allow for students to get it wrong the first time and come back and redo it again. So we do have, though, a heap of resources that you can use if you need to.
So we've been through a couple of the project ideas, but I'm just reminding you that project ideas are really good if they have an audience, if they have a purpose, and that students be able to meet all of the content descriptors with that project as well. I've always found in the past that any project that involves entering for a competition or, something that people actually see in real life has a real life purpose, and they get quite enthused by those sorts of projects along the way. Sometimes, as Drew said too, it's really nice to co-create some of those with the students so that they feel that they've had a little bit of input into them. Grok's got a couple of resources with all of the design thinking that is involved in projects. And because design thinking is something that is quite specific to version 9, you might need your own toolbox filled up there. So there's a couple of online courses which are pretty cool. So we've got the design thinking one. It uses a lot of cartoons, checks for understanding along the way, and takes students all the way through investigating a problem, empathizing with your user, defining the problem, ideating, coming up with different designs and prototyping. It also goes through the evaluation iteration stage. So this is quite nice, and it is geared at our students' level. Some of the teachers were pretty enthused when they looked at that one as well. We also have a UI UX one, which is very useful if that's where your emphasis will be. And it has some practical drag and drop. So the things you can see on the right-hand side are dragged and dropped over in order to get the question right. It also has that cartoony feel to it, a lot of checking for understanding again. And this course here goes through elements of design, what's poor design, how to understand your user stories. There's one we heard today, prototyping, wireframing, which we also did today, accessibility, gaining feedback, very important. It also goes through things like colors, iconography, and typography, and again, that iteration phase. So a nice solid course there. So they're all free at the moment for teachers and students. And another one that works really well is the teacher workbook. You can download a PDF copy, or if you see us at one of our stands at conferences, we'll happily supply you with one. It comes with some blackline masters at the back. It comes with lesson plans and class activities. The curriculum's aligned. And also another valuable one is the role cards at the top right. Those ones are really cool, where students actually understand what their role is in the team, and they're clearly defined as they go through. So having a handle on this book is valuable when you come to projects and that sort of thing. Some of our courses, they've got the links there for you. I've got the book there. And you got Microsoft Planner, GitHub. Your school might also have some sort of online collaboration learning management system that you use that is approved. Every school's different, every place is different, but having some good resources behind you is really valuable as well. So we'd like to say thank you for joining us today and going through the project course. Where we are free, as we said before, all our courses, our resources and our content are now free for every Australian student and teacher, thanks to last October's announcement between Grok and WiseTech Global. They're working to make digital technology skills and the learning of those free and available to every student, teacher, parent, adult learner for free. So our mission is to educate all learners in transformative computing skills, knowledge and dispositions, and our partnership with WiseTech removes the financial barrier for schools in using our resources, as well as allowing us to expand our team to support schools, teachers and learners. Thank you so much for joining us today. We've really enjoyed it. Thank you, Drew. You've been a valuable support person on this one. And we hope to see you again in the next few months with other courses around the place. Thank you.
Thanks, everyone.